Alright, Logic fans, welcome back. This is video 2.3b, our second video on section 2.3, logical equivalence. I want to contrast the notion of logical equivalence with the notion of material equivalence from section 1.6. Before we do that, pop quiz on what we covered in the previous video, 2.3a. Some interesting features of logical equivalence. True or false? Every proposition is logically equivalent to itself. Okay, I pick a proposition out of a hat. Is that proposition logically equivalent to itself? Guaranteed. Yes or no? Okay, that's true, right? It's going to be logically equivalent to itself because you're going to think about the corresponding biconditional, which is, if I picked out the proposition alpha, then I'm going to think about alpha tribar alpha. And that, of course, is going to be a tautology because alpha will always take the same truth value as itself, right? And so it's always going to be true tribar true or false tribar false, okay? So alpha tribar alpha is always going to be a tautology. If you don't believe me, sit down and work out a truth table for it and see it for yourself, okay? So this is absolutely true. Every proposition is logically equivalent to itself. Let's try another. All right, question 2. True or false? If one proposition, call it alpha, is logically equivalent to another proposition, beta, then beta is logically equivalent to alpha. Pause now. All right, this again is going to be true, right? If alpha is logically equivalent to beta, that means, right, among other things, that alpha tribar beta is a tautology. So alpha and beta are always taking the same truth value, either both true or both false, right? But then beta tribar alpha, those are always going to take the same truth value, and therefore beta tribar alpha is going to be a tautology as well, making beta and alpha logically equivalent to one another. All right, let's do another real quick. All right, let's try a little more sophisticated one here. So if both of these are true, then this is true, okay? So if the first proposition you pick is logically equivalent to a second one, and that very second one is logically equivalent to a third one, then it follows that the first one you picked out is logically equivalent to the third one. Is that true or false? And the answer is yes, this is absolutely true. Okay, this is absolutely true because, and you can just work it out on a truth table and you'll see it. In fact, that's a great exercise. So go ahead and give that a shot to see that for yourself. Okay, maybe I'll draw your attention to a couple other, to one more idea here. So, true or false, no tautology is logically equivalent to a contradiction. All right, so this is kind of fun. We're kicking around all these ideas. All right, so this is true, right? And so is the, and vice versa. No contradiction is logically equivalent to a tautology either, right? First of all, on a truth table, so if you just picture a truth table, the tautology, if I have the tautology here, it's going to go true, 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 true. If I have the contradiction, it's going to go false, 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 right? And so if I have true, 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 tribar, false, 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 those are all going to come out false, making the corresponding biconditional a contradiction, in fact, and not, at any rate, it's not going to be a tautology, and so no tautology is logically equivalent to a contradiction. Again, work out a truth table. Take, for example, like this sentence, which we know is a tautology, and take, for example, this sentence, which we know is a contradiction, and see if they're logically equivalent to one another or not, okay? All right, and that's just a particular instance, but it'll give you, it'll reassure you that everything I'm saying here is true. And very similar things hold for, like, no contingent is logically equivalent to a contradiction. No contingent is logically equivalent to a tautology, right? Only tautologies are logically equivalent to tautologies. Only contradictions are logically equivalent to contradictions. Now, not all contingents are logically equivalent to one another. For example, right? Here's a contingent sentence, and here's a contingent sentence. Okay, if you run a truth table and you consider the corresponding biconditional, the corresponding biconditional of this will not be a tautology. Okay, and so just because you have two contingents doesn't mean that they're automatically logically equivalent. All right, so that's an important point worth noting. Okay, what I want to jump into now is noting those sort of various features of logical equivalence is the contrast between logical equivalence and material equivalence from section 1.6. So it may pay to go over section 1.6, but so first let me state the difference between the two, and then we'll look at an example to drive home the point, all right? So stated, the difference between the two is as follows. The corresponding biconditional of a pair of logically equivalent sentences is logically true. It's a tautology, okay? The corresponding biconditional is a tautology. Whereas the corresponding biconditional of a pair of material equivalent sentences is true. Okay, so logical equivalence is stronger than material equivalence. If a pair of sentences are logically equivalent, then they're materially equivalent. But a pair of sentences can be materially equivalent and not logically equivalent, okay? So it all consists in understanding this last part here, whether the corresponding biconditional is logically true or whether it's just true, but not necessarily a tautology, okay? All right, so let's look at an example to drive this difference home. Okay, so let's try an example together here, all right? So I've got a pair of propositions here, and I've got a pair of propositions here. Now, one of these pairs, let's put it this way, this pair of propositions and this pair of propositions, they're both, this pair of propositions is materially equivalent. So you have a heart is materially equivalent to you have a kidney. Likewise, all triangles have three sides is materially equivalent to all triangles have three angles. Okay, what that means is that the corresponding biconditional of this pair of sentences is true, and the corresponding biconditional of this pair of sentences is true. However, only one of these pairs of sentences are logically equivalent. Okay, so your task is to figure out, or our task together, we'll work through this together. Our task together here is to figure out which pair, 1 and 2 versus 3 and 4, are in fact logically equivalent, even though they're both materially equivalent. Okay, so step 1, I want you to find the corresponding biconditional of this pair of sentences, 1 and 2. I also want you to find the corresponding biconditional of this pair of sentences. Okay, so pause now and do that. Okay, so the corresponding biconditional of the first pair of sentences just is all triangles have three sides if and only if all triangles have three angles. Okay, and the corresponding biconditional of the second pair of sentences is you have a heart if and only if you have a kidney. Now, notice, let's just ask ourselves, is this biconditional true or false? And is this biconditional true or false? Pause now and we'll work through it together in a second. All right, let's go ahead and start with this one. Notice it's a biconditional, so it's just two conditionals, right? And so the biconditional is true provided that both the conditionals are true. So if all triangles have three sides, then all triangles have three angles. That's true. That's the left to right direction. The right to left direction, if all triangles have three angles, then all triangles have three sides. That's also true, right? So this is a true biconditional. Therefore, this sentence right here is materially equivalent to this sentence right here, right? Okay, let's go through this one. Is this biconditional true or false? Well, if you have a heart, then you have a kidney. That's true, right? And if you have a kidney, then you have a heart. That's also true. So this biconditional is true. Therefore, this sentence, you have a heart, is is materially equivalent to you have a kidney because the corresponding biconditional is true. Okay, so both of this sentence is materially equivalent to this sentence, and this sentence is materially equivalent to this sentence. Now, let's keep going and see if we can figure out which of these pairs of sentences are logically equivalent to one another. And you might have an instinct about that, right? Well, looking at it, it's going to turn out that all triangles have three sides is logically equivalent to all triangles have three angles, right? right? It's not like there's going to be a circumstance where you have a triangle with 3 sides and it doesn't have 3 angles, or vice versa, okay? But you could have a logically possible circumstance, maybe, I don't know, during a surgery or something like that, let's say, or some exotic creature as evolution unfurls into the future, okay, that has a heart but lacks a kidney, let's say. So, it could be that you have a heart and you don't have a kidney, let's say. So this is not going to be a tautology. This biconditional is not going to be a tautology, and therefore you have a heart is not, logically equivalent to you have a kidney, right? Because the corresponding biconditional is not a tautology, and that's the difference between the two, all right? So whereas these propositions are logically equivalent to one another, these ones are not logically equivalent to one another, even though these ones are in fact materially equivalent to one another. And remember, if a pair of propositions are logically equivalent to one another, then they are materially equivalent to one another. But the opposite doesn't have to be true. You can be materially equivalent and not logically equivalent. All right. So let me give you another example to drive the point home. For the purposes of this example, let's suppose, just for the sake of argument, the only thing that exists is Elton John. So for those of you who don't know, Elton John is a pianist, amongst other things. Okay, he plays the piano very well. So the only thing in the whole wide world is Elton John. Okay, there's no grass, there's no oxygen. It's a very bad state for Elton John. But the only thing in the whole world is Elton John. Okay, just for the purposes of this example. All right. So I've got a couple of propositions here, A and B. The proposition A stands for you are a human being, and the proposition B stands for you are a pianist. Okay? Now, let's just think about this for a second, all right? Here's a pair of propositions, A and B. Here's a pair of propositions, A and A. Now, can you figure out whether this pair of propositions is materially equivalent and whether it's logically equivalent? And likewise, for this pair of propositions, can you figure out whether they're materially equivalent and whether they're logically equivalent? Pause now. Okay, so it's pretty nifty here, but this is how this works out, okay? The first thing you have to do is you got to figure out the corresponding biconditional of both pairs. Okay, so the corresponding biconditional of this pair of sentences is A if and only if B, and the corresponding biconditional of this pair of sentences is A if and only if A. All right. Now, if you work out the truth tables for this, you'll see that sometimes A if and only if B is true, and sometimes it's false. When you work out the truth table for this, you're going to see that it's always true, and that therefore this sentence is a tautology, and therefore this sentence or proposition is in fact logically equivalent to this proposition. All right, and therefore A is materially equivalent to A, but it's also, more importantly, A is logically equivalent to A. Now, is A if and only if B a tautology? No, right? There are cases where it's false on your truth table, and so these are not logically. This is not a logical truth. This is not a tautology, and therefore A is not logically equivalent to B, but they are materially equivalent in this situation, right? How do I know that, as a matter of fact, A is materially equivalent to B? Well, because this proposition is true, right? So there's different circumstances on your truth table. Sometimes it's true, sometimes it's false, but in this actual circumstance, as a matter of fact, it's true, right? Because if you're a human being, then you're a pianist, right? In this circumstance. If that's the only thing in the world, if you're a human being, then you're a pianist, is true. Also, if you're a pianist and, the only thing in the world is Elton John, then you're a human being. So this turns out to be true. This is a true sentence, and therefore A is materially equivalent to B in this situation, right? But, even in this situation, A, if and only if B is not a tautology, and therefore A is not logically equivalent to B. So each of these pairs are materially equivalent to each other, but only this pair is logically equivalent to one another. This pair is materially equivalent and not logically equivalent. Okay. All right. We're going to spill onto one more video, which will be a short one. Look for 2.3c.